All right, let's go ahead and get started. So welcome everybody. My name is Josh Broltheim. I am the lead technical trainer at Sumo Logic. And today we're going to be going over, as the screen hopefully says, Sumo Security Analytics, specifically the Security Analytics certification, excuse me. So what we're going to be using today as our guide, get out of that window, is the certification course. So hopefully by now you've taken at least one of the courses with us previously. If you haven't, that's fine. But typically, most people would start with fundamentals, work their way up to search mastery, et cetera. And so we're going to be doing security analytics. Security analytics is going to be purely labs. If you've taken search mastery, it's going to be pretty similar, but more with security use cases in mind. So while we're still going to be doing queries and looking at them and how they work, it's going to be with, like I said, kind of a security hat. So that's what you'll just want to keep in mind. Let's get you guys logged in. So that's gonna be the first step, is getting you logged into our training environment. So here are the credentials. I'll put them in the chat as well. Hopefully you've used these before. If not, welcome. And so these are gonna give you access to the training environment login. The nice thing about the login, or the environment rather, is the fact that this is a sandboxed environment with different sets of data that you can jump into, mess around with, and you're not impacting anything. So I'll give everybody a few moments to log in. Okay. If anybody needs help with the credentials, if you want to go ahead and just post in chat or Q&A. And I should have mentioned, I have one of my peers, Nicholas, on the call today. He'll be monitoring the chat and Q&A for any questions you guys might have. So if you have questions, just throw them in there and he'll answer them, or to the best of his ability. So let's get started. So hopefully you were able to log in successfully. And if you did, you should have been brought to the home page, which, hopefully you've seen these screens before. I'm going to kind of assume you have. But what we're going to do is get straight into the lab. So the way we're going to access them is to go to certification. However, we're not going to take the exam right away. Kind of jokingly, if you want to take it right now, you can, but you probably don't. So let's go ahead and learn what we need to take the exam successfully. So we're going to go to security analytics, and on the far right, we should see hands-on labs. So if we just click on that link, we should get some labs. So we should have our original tab or app and then the labs. And so just once again, just in case anyone just jumped in, we'll be on home by default. We'll go to certification, security analytics, hands-on labs, click the link, and now we have labs. All right. So these labs, there's about 20 of them or so. Yeah, give or take. We're going to do most of them today. We'll skip over a few here and there, but we will hit most of these. And yeah, let's really start just going through them. So the way we're going to go through these is similar to if you attended our Search Mastery class, where I'm going to do them on the screen, you'll do them on your device, and if any questions come up, let us know. So each lab, we're trying to show either a feature or a functionality, or some kind of end result, if you will. We are going to be similar to Search Mastery, just pasting the queries in. So for today, we're not going to be actually creating our own unique queries. We're actually working on a class where we will do that, but it is going to be a lot of cutting and pasting. But I find this to be an effective way to learn, because what we'll do is we'll go through each line. So what is this line doing? What is this next line doing? And so on and so forth. So let's go ahead and start with Lab 1, Search Basics, Metadata, and Keywords. Now I'm going to go through this one. There's only a couple steps to it, but kind of quickly, only because I feel like you probably have seen this at some point. But let's go through it anyhow. So in Lab 1, we're going to go over, like I said, Search Basics, Metadata, and Keyword. And so we're going to start with Lab 1-1, and that's the numbering convention I'll use. So 1-1, 1-2, 1-3, etc. So in the first lab, what we want to do is search for all messages for the last 6 hours with the source category of labs AWS CloudTrail that contain the word root. So how do we do it? Well, the query is right down below, but let's go ahead and grab it and then talk about it. So I'm going to go back into my app. I'm going to go to a new log search, and I'm just going to paste that query in. Now, before I run the query, I wanted to run the last 6 hours. 15 minutes is the default, and that's why we're putting it to 6 hours to remind you that while it is the default, you can modify it. And now when I click start, very simply, the system is now looking through the last 6 hours worth of data, looking through the log messages that have this source category applied to it, and then through those log messages looking specifically for the keyword root. Now, something I'll point out on this screen that you might notice yourself is down below in the log messages, we see those messages that should match the keyword root. But if I look at the log message here, I'll free up the screen just a little bit, get a little more real estate on there. I don't see the word root anywhere in here. So why is the message being brought back if I don't visually see the word root? Very simply, the root is nested. So if I go to this user identity field and click on the arrow, it's a nested field. So the root is showing up as a type as well as the ARN. So even though it's not visual on the first kind of this first flat screen, if you will, if you do drill in, you do see root. So that is fulfilling our kind of our mission or our query of looking for that keyword. Now, in the next step, lab 1-2 rather, excuse me, we're going to look across all the AWS data. And the reason we're doing this is really just to remind you of the wildcard feature. So in this case, while we're looking at AWS CloudTrail, if we want to look at all the AWS data that contains the word root, we can just use the wildcard. And now same thing, that's why the root is hidden down below. Now in the next lab, or the next step of this lab at least, 1-3 is introducing or possibly reintroducing LiveTail. So LiveTail is pretty helpful. I'm going to go ahead and put my query back to the same as lab 1, which is what we're recommending, although it doesn't really matter too much. But let's introduce LiveTail, or at least remind you of it if you're not familiar with it. So when I do this query for the last 15 minutes for AWS CloudTrail and root, I'm kind of looking at, if you will, old data. Now, old is a relative term, but it is data that's come in and has been sitting there, potentially up to 15 minutes, which is good. And that's not a bad thing that I'm looking at old data. But what if I want to look at the data as it's coming into Sumo Logic? This is where LiveTail can help me. So to get there, I can either click on LiveTail or I can go to New LiveTail. We give you many options in the system. So I'll just click on LiveTail. And what that is going to do is going to take my query, my basic query with a keyword and metadata, and then push it through to examine the new data as it becomes ingested into Sumo Logic. Now, I don't know if we have much CloudTrail data coming in. Oh, there we go. There's a little bit. And so now what I'm seeing is data coming in, data coming in, data coming in. This is prior to hitting some ingestion rules, hitting things like field extraction rules, et cetera. And so that's why you can only use keywords. We couldn't say, for example, show us the, where did root show up? We couldn't say, show us the type that's equal to root here, because the system doesn't know what a type is yet. So this is a great way to see certainly what data is coming in or being ingested. And also a good way when you're starting to set up the system to verify data is coming in. If you're in charge of setting up collectors, you might install that collector, get it set up, think data is coming in, do a query against that data, and you get no results. Well, come back to the LiveTail and see, are you getting data into the system? If you are and you can't query it, you certainly have one problem, but if it's not even coming in, then you have another problem, and that can help diagnose this. There's also, which you probably have heard before, a command line interface for this as well. So if you'd prefer to keep more of a traditional terminal window open, you can do that. So I just want to remind you of that feature. All right, lab 2 is going over parsing, grouping, and filtering. And I'm just going to grab the whole query and just talk through it. Many of these things, like I mentioned earlier, you probably have seen in Search Mastery, but we're trying to tie it all together. So let me grab the query and let me come back and talk about it. So the goal of this lab is to search the CloudTrail logs to identify the top 10 IP addresses for the US West region. And you may have heard me say this before, but I like to read these things as, or interpret them almost as a math word problem. Because what am I trying to solve for? Or what am I trying to have the system really solve for? Well, I need to tell the system how to solve for or find CloudTrail logs. I need to tell the system how to calculate or determine an IP address. I need to tell the system how to calculate and determine a region, and then specifically just the US West region. And then I need to find the top 10 IP addresses for those US West regions. So those are kind of my X, Y, and Z's, if you will, almost. So let's take the query and just run through it. And I'm going to go ahead and comment off some of these lines. To do that comment, you'll hold down, if you're interested, because many people are. If you, on a Mac, if you hold down, go to the first line and go to hold down the Alt Option button on your keyboard, it turns into some crosshairs. With your finger still on that button, click on the mouse and just drag down, and then any lines you type will be replicated. So a little handy tip for you. But back to the query itself. So the first portion, we're looking at lab AWS CloudTrail data. And I'm going to keep the last 15 minutes because the query or the lab didn't have me specify last 6 hours, last 3 hours. So I'll just keep the default. Now we're going to go ahead and look at this CloudTrail data. And what I want to show with the CloudTrail data, although you just saw it a moment ago, is the fact that it's different. It has these nested fields. It even has these almost fields or apparent fields in the query, in the log message. So here, for example, I see a field called AWS Region and a value for that region. Here I see the IP address or source IP address and a value for that IP address, et cetera, et cetera. So my goal now is to look for regions and then just specify the US West one. So how do I do that? Well, many ways to do it within Sumo logic, but in this case, we want to show you the easiest way possible. And that's using the JSON operator. These log messages are in a JSON format, which you might recognize because of the nested fields or the fact that they have this kind of source, this field and this data point after it, or the fact that it just says expand JSON up here. Since these are in a JSON format, though, rather than parsing this information out using regex or parse anchors, which still would certainly work, but you could use all day, we can use the very simple operator of JSON. What field of the JSON do we want to kind of explode out? We want to do that AWS region. So now when I click start, the system is now going to go to each log message, look for that AWS region, find it, or in the cases where it can find it, parse it out with a value. So there's US West 1, there's US West 1, there's going to be a lot of US West 1s. And now if I want to say specifically, just show me where the AWS region equals US West 1, well, this is where I would do so. In fact, prior to this step, I can use the field browser here. So so going back, I've now identified the AWS region, and maybe I'm asking myself, what AWS regions exist? I certainly see US West 1 here, but is there a US West 2? Is there a US East 2? I don't really know. By clicking on the AWS region field browser field, now I can see over the last 15 minutes, here are the values, and here's the count, and even a percentage breakout. Because my job, let's say my job is not to go this deep, but let's say my job was to figure out over the last 15 minutes, how many, what region has been most dominant in our data. Well, I can do that just by clicking on this, and I didn't have to count it. I didn't have to chart it up or anything. So this is where a field browser can really help me out. So I'm going to go ahead and just say the US West 1, because that's what we want to look is just for that US West data, and only US West 1 exists. So now I only have US West 1 data, and I can confirm that by going to the AWS region and seeing there's only one value. And if I click on that field, I see that only singular value. So this is good. We have regions, we have only US West, but we now need to go ahead and do the IP addresses. Now, how do we do those? Now, we could technically go ahead and just say JSON AWS region and JSON source IP address, which would work perfectly fine and actually would be the recommended solution here. But what I wanted to show is the fact that you can use two different parsing mechanisms within the same query. So here I'm using JSON, and here I'm using parse regex. I could use parse anchor. I could also use a field extraction rule. We just want to show that you can mix and match these. So now that I'm parsing out for an IP address by looking for number.number.number.number, I now see those values down below. And now, or continuing on, my goal was to identify the top 10 IP addresses for those US West regions. Now, right now, I only have US West regions and IPs, but I don't know how many of each one I have. So before I can say, show me the top 10, I just need to count them. And that's what I'm doing on this line. Take those IP addresses and just count them up. Count, as a reminder, is a mathematical operator. Since I'm doing math, I get my results in an aggregates tab. And now I see the results. And what this is showing me is there are 25 pages and 25 per page. So there's probably about 600 different IPs. Well, my goal is to find the top 10. So how do I do that? Using the top operator. How many do I want to find? The top X, the top what? The top 10. The top 10 what? The top 10 IP addresses. Do I want to find those top 10 IP addresses by size or by numerical value? Or, well, no, I want to do it by count. So now when I click start, very simply, the system's going to take those counts, sort them, keep the first 10, and drop the bottom 620 or so. And now I've kind of fulfilled my request. The last portion of this lab is reminding us, so it's asking to, but the reason we're doing so is to remind us that there are other charting options. So while this might be a suitable way for me to view my data, maybe I prefer to view it in a line chart. That doesn't really look good. Area chart, pie chart, that really makes more sense. And if I zoom out a little bit, now I can see those values around the ring. So now I'm seeing for each IP address of the top 10, how many there were and the percentage. And now I have a pretty little graph that I can share with somebody or just utilize on my own. All right, cool. I don't see any questions about those and wouldn't really expect any, but if there are, feel free to provide them. Lab 3 is very similar to something we cover in Search Mastery, but I think I'm going to go through it very quickly because the no drop is worth re-understanding if you haven't before. So let's take a look at this query. And I'm going to pull up the query, pull up the data, and then explain what the feature is. So kind of going a little bit backwards, but let me just zoom in as well to make that screen much clearer. Okay. Oh. Okay. There we go. Sorry about that. So for this set of data is going to be the Apache error data, which you may have seen before. And what we want to remind you of with this set of data is the fact that some of these log messages have a client and an IP address after the word error, and some of them do not. Now, if I tell the system to parse using a parse anchor to look for that bracket client space star, whatever that star is, that's the IP address, when I run this, it's only going to retrieve those messages that have the IP. So if you want to include those messages that do not have the IP or do not match the pattern, this is where no drop comes in. And that's really what I just want to remind you about. No drop is going to display the result regardless of if it has an IP or not. If it has an IP, you have a field for an IP. If it does not, then you have no value, but the log message still shows up. And so that's what I wanted to point out. I'm going to skip over the other ones in Lab 3 to be perfectly honest. Let's get into the security stuff, which really comes in Lab 4. So Lab 4, what we have here is we're going to go through 2 of these. There's actually 3 on this page, but we'll just do 2 of them. And what we're going to do is, as it says here, using simple operators in AWS security use cases. So to play with this lab or do this lab, we're going to point you to a community post. So just go ahead and click on that link, and now you'll have another tab open. Now, once you have that tab open, let's go back to the lab and just talk about which one we're going to be doing. And the first one we're going to do is the monitor AWS root account usage. And then we will do the monitor user login from 2 different IPs. So we'll skip this middle one. I don't really like this lab, and I need to rewrite it a little bit. But let's go through the A and the C portion. So let's go to the community post that opened, and let's take the query and look at it and figure out why we're even using this query. So what we want to do here, or we want the system to do for us really, is to monitor AWS root account usage. As it says here, minimizing the use of the root account is the best security practice. Root has unrestricted access. So what we want to do is we want to see who is running root and for what purpose. And that's what the query is going to help us with. So I'm going to grab the whole query, copy it, paste it into a new query window, and just talk through the steps. So the first step, we're doing the lab AWS CloudTrail and root again, same way we did earlier. So once again, root is showing up as a keyword, even if it's not visually obvious, it is there somewhere. Then the next thing we want to do is we want to start to break out things about our root users. So we want to start to find IP addresses, identity, which will let us know what access they have and things like that. And so that's what we're doing here with this JSON. Rather than parsing this out using field extraction rules or regex or parse anchor, we're doing it through the JSON. And probably in the real world, doing a field extraction rule here would be recommended because it'll just save you these steps. Now, the next step here is to take, and I'll go back to the message, but that user identity portion I pointed out earlier, I want to now grab this type and this ARN because I need to figure out who is a user that the type root And then the ARN is like a username in AWS world. So in this case, our username is 12345. But how do I get that information? I can't parse it out in the same way that I do with JSON. I first need to parse out that upper level JSON, and then I can parse out the lower level. So now that I've parsed out a user identity, now I can say within the user identity, parse out the type and the ARN. And that's what I'm doing right here. Now I'm saying specifically look just for the type equals to root. Previously, I was using root as a keyword. And so if root showed up as the username, as anything in here, that would fulfill the request. But I really want to see where the type is equal to root. I want to see where those users that have root access. So that's what I'm saying here. It's just show me type equals root. Now, this next step is kind of a weird step. It's really an AWS thing. In fact, we don't really need it, but I'll mention it just because somebody's going to ask about it. Apparently, in some of the AWS logs, sometimes an IP address, which traditionally is, an IP address, can show up as something.Amazon AWS something else. And I don't fully know why, but I'm not a CloudTrail expert, but that can appear. And so what we're saying here is to really just kind of ignore those. That's what the not symbol is doing. Now we're just going to take our time. So here we have our message time. And what we're doing here is we're cleaning it up. We're saying take that message time and format it and return it in this format. So rather than having it month, day, year, we'd prefer a standardization of year, month, day. And that's what we're doing with that. So now when I run this line, now I still have my original time, but now I have my date formatted to my preference. And now what I need to do is count all this stuff, because I now have log messages for each time somebody as root has done something and their day and all that information, but I need to kind of aggregate it. I need to tie it all together. I don't want to just look through 344 records. I want the system to kind of pop back at me and let me look through this easier. And that's what I'm doing here with the count. Basically, I'm saying just take the date, event name, all these unique things and just count them up. And by doing so, that's when I get my aggregates tab and I get my data just formatted a little bit better. Same data, the data hasn't changed and I still have access to those raw messages, just visually it's a little more pleasing. And now this is what has been returned. Now I can sort by date, not really necessary, but I guess I should do it. Now what do we see here? What is this outputting to us? What this is now showing us is this user at this time from this IP address did this action. Now, this is where, as I alluded to earlier, you kind of need to put your security hat on, because what I'm showing you here is user 1234 did a scheduled key deletion. Oops, sorry. He did a described delivery channel status, all these different events, disabled keys, etc. Now, is that bad or is that good? Well, I can't really tell you that, and that's where you need to decide. Is user 123's job to do all this stuff? Yeah, then good, he's probably doing his job and all is well. Is user 123 on vacation for the past week? Well, if he or she is and all the stuff is going on, that might be problematic. Maybe he or she set up a automated process to do this. And so that's where you kind of need to dig in and figure out, here's what's going on, here's what the data is showing me, and now let me decide, are these good or bad things, or whatever you do with that. So that's a good example. The next example I like to show, and if there are any questions, like I said, yep, no questions, cool. Now we're going to do the lab 4C. So in this case, we're going to monitor a user's login from 2 different IP addresses. So we're just going to scroll a bit further down. We're going to skip this permit any, and then we're going to go to this monitor a user logins from different IP addresses. Now, why are we doing this, or what are we doing with this query? What we want to do is identify users that have logged in from more than one IP for a specific time period. So we're trying to see where a user has successfully, and successfully is important here, logged in from more than one IP address during a period of time. So let's grab the query and talk through it. Okay, so let me paste it in, comment off, one more in there. Sorry about that. All right, so in the first line, grabbing that CloudTrail data again, but this time we're going to look for the keyword of console login. And the reason we're looking at that is because later on, we're going to eventually look for the console login equals success, because we want to see those successful logins. So we're going to bring the keyword in up here because we only want log messages that have a console login string in it, essentially. So rather than bringing all the CloudTrail data back, just bring those messages that have console login. And then later we can decide how we want to use the console login. So when I click start, I get those log messages. As shown earlier, these log messages have the JSON, so we're going to go ahead and parse just stuff we need from them. We're going to grab that user identity, that type and ARN again, that's pretty key. We're going to grab the JSON field of console login, and I'll grab this other event data while I'm here. And then we're going to say now here where console login equals success. Because like I said, I don't want to view console logins that are a fail. Now I might, but not for this use case. This one I want to see where have people logged in successfully. And that's what I'm doing with the console login equals success. So now I have a bunch of log messages that show me all this stuff, but I need to group it together because I need to find where users are logging in from multiple IPs. I don't want to just look at each log message. I want to look at it in a table. So that's why I'm going to count by ARN, which is, like I mentioned earlier, is essentially username, and then source IP address because I want to see where they logged in from different IPs. So now what I've done is counted by those two things. And what I see here is this user, B. Smith, logged in from this IP address during the 15-minute window. He also, or she, logged in from this IP address, and so on and so forth, which is good, but I want the data to be cleaned up a little bit because in this data, well, there's only 3 pages, this could be 300 pages, and I want the system to show me where users have logged in multiple times. I'm just seeing each unique login from the past 15 minutes, but I want to group them together to see, did B. Smith log in more than once? Now, like I said here, it's pretty obvious he did, but maybe there's a J. Smith under here, and I don't want it to go through each page. I want the system to give that information to me. So what I'm going to do now is take this information and just clean it up. The data is not changing, just my expression of the aggregates tab and the formatting of it is. So the first thing I'm going to do is sort by ARN, or essentially sort by username. Group all the B. Smiths together, all the J. Smiths, all, et cetera. Then what I'm going to do here, and this is not needed, this is just kind of a cool is the right word, but a unique way to clean things up, is what we're doing here is we're saying 1 as a row number. So what I'm doing here is I'm creating a field called row number, and very simply, I'm just putting a 1 in each row number. Now, why am I doing that? The reason I'm doing that is because now I can go ahead and say, take the ARNs and total them up by row number. So now what this shows me is B. Smith has logged in 55 times over the last 15 minutes from different IPs. Now, this list still might show me that J. Smith has logged in once or twice from a different IP. And I want the system to only show me where that person has logged in more than once, where the total basically is greater than 1. Because if they logged in 1 time over the past 15 minutes, that's normal, that's not concerning, that's something I don't really care about. It's those multiple logins I'm looking for. So when I do that, it now will only keep those where the total is greater than 1. And now I can clean up these fields I don't need. I don't need this row number, this count number field anymore, or count value. And so now what I see is B. Smith has now logged in 55 different times, and these are all the different IP addresses. Now, once again, is this bad? Is this good? I can't really tell you that. If B. Smith's job is to access VPNs around the world and check, your security or something, then yeah, he or she are doing their job. If B. Smith is on vacation, this is probably quite concerning. Maybe you speak to their manager and they're on vacation, but they're doing work, then it's not as concerning. And so that's where you need to, dig a deeper level to, check with personnel, check with managers, to see should these people be doing these things. But we can tell you what they're doing. All right, cool. So I hope those two were pretty helpful. We think those are pretty good real world examples. And the other cool thing about those is if you're using CloudTrail data, you can just take this query right away and paste it in. Modify your source category to where your CloudTrail data is, but the rest of it is all standard CloudTrail formatted data. So feel free to take those and use them or modify them. All right, let's go to Lab 5. Let's see. So I'm trying to root out some of these that you guys might have done before. Let's see. Let's go. Yeah, let's do Lab 5. Sorry, I was being a little indecisive. I just want to go over log reduce again. You've probably seen it before. I certainly hope you have. But if you haven't, it's really worth going through again. It's just such a helpful feature that a lot of users forget about. So I'm going to show lab 5 and 6 kind of together with log reduce and log compare. But let's take a look at these. So in this example, I'm bringing in snort data, and snort is security event data, not data that's being generated by Sumo Logic, but another outside system that is determining these security events, and then that data is being ingested into Sumo Logic. And what we want to see in here is this portion right here. We have in each log message a classification of a different security event that has taken place: attempted denial of service, web app attack, etc. And there's been 6,000 of them over the last hour. Now, this is where I can go ahead and choose to use log reduce to distill all this information down. Because what if I want to see all those different classifications? How do I do it? Well, by using log reduce, I'm using essentially an easy button, and the system is now taking all those logs, those 6,000 logs from the last hour, looking at them, grouping them, doing its kind of magic, special sauce, AI, all those fancy tech words, and then showing us those results. So what I see here now is of those 6,000 log messages from the past hour, just about half of them are attempted information leaks. 640 of them are, 45 of them are sensitive data, and so on and so forth. Now, this is really helpful because this is a great way to just take this information and distill it down. The proper way, of course, if I really want to look at these classifications, would be to parse, anchor, looking for bracket, classification, colon, space, and then whatever's in that space, that is the type of classification, and then count them. But this is, like I said, an easy button where it does all that work for you. Now, this is a good portion to be at. We know that there were 3,000 of these messages, just about half of them were attempted information leaks. But what I don't know, and this is, I'm going to go into lab 6 now, is that a lot or is that a little? I mean, it certainly sounds like a lot, but I don't really know. I need to compare it to something else. And this is where log compare can help me out. When I click log compare, what happens is the system now takes that last hour of data, takes a 24-hour time shift to yesterday, to that same time period, and looks at that data and shows the results. So right now we're essentially looking at data from 11:30 to 12:30 West Coast time today, 11:30 to 12:30 yesterday, grouping both sets of data, and then showing us the difference in this number here. So this is now letting us know, while 3,000 might sound like a lot, it's actually decreased by 0.33% from yesterday. Now, granted, it's not much less than yesterday, but it is, and that might be good. That might be important to know. Similarly, we have things, here's a good one. This attempted denial of service message has increased by 50% from yesterday to today. Well, that might be helpful to know. Now, there's a lot more of them. Maybe we need to protect against those or lock some accounts out, or kind of, once again, kind of go to our playbook and decide how to react to these things. As a reminder, while the default for log compare is 24 hours, you can modify that. So maybe instead of comparing Wednesday and Thursday, it makes more sense to compare this Thursday to last Thursday. That's where -7D will allow you to change that. And now we're looking at today from 12:30 to 1:30, or 11:30 to 12:30, excuse me, and looking at 11:30 to 12:30 last Thursday, and then seeing those differences in those results. Okay, cool. Let's see, anything else in lab 6? No, the rest you probably have done previously, so I think we'll skip over those. Lab 7 is Outlier. So Outlier you may have done before, but I think it's worth doing again. One, this is a different use case, so I think that might help. And it's just that important of a feature. It's something that can really help you guys out. So let's take a look at it. So we're going to use the same data we were starting to use, which is that snort data. And what we're actually doing here is what I was just alluding to. So in this case, we want to get these specific classifications. So in this case, we are going to go ahead and parse anchor using bracket, classification, colon, space, and really figure out what those classifications are. And that's what this parse line is doing, saying, look at the star. So basically look for the bracket classification, Everything before that, just call it date, info, and file. We don't really need it, so just kind of lump it over there. Everything after, keep these things. So when I click start now, that log message is kind of extrapolated out into different fields, and now we have a field for classification, and then fields for IP address, priority, but I'm not going to utilize those. What I am going to do though in this lab, I'm sorry, I should have mentioned it, is we want to look at the anomalies associated with the frequency of denial of service attempts or DDoS attacks. So what we want the system to help us with is DDoS attacks may happen, but what we want to know is when an anomalous amount happens, when we have more than normal or less than normal. Really, we're probably just going to know more than normal, but we can decide that with the outlier. So at this point, we've now defined these different classifications, but now I can go ahead and say, only show me where the classification is attempted denial of service, because that's all I want to see. Now we need to start to clean up the data, because now I'm just looking at a count of those different denial of service messages over the last 15 minutes. I'm going to bring back a little bit more data, just I think will help the data be more expressive. So I'm going to do the last 3 hours should be enough. And now I'm going to introduce the time slice operator, because while I'm looking at my data from the last 3 hours, I don't want to look at it in a bucket of data from essentially 9:30 to 12:30 local time. I want to see how many attempted denial of services messages did we get from 9:30 to 9:35, 9:35 to 9:40, etc. And I can modify this if I want to see these in 15-minute buckets. I can do that as well. Just I need to decide, how I want to see my data. Now that I've used the operator of time slice, now I can use the results of time slice, and that's what this line is doing. This line is saying, take the classification, which is only going to be attempted denial of service, and count it, and do the counting by time slice or by the results of the time slice operator. So now when I run this, since I'm doing count, I get the aggregates tab, and now I see at 10:25 to 10:30 there were 5 denial of services. From 10:05 to 10:10 there were 12, and so on and so forth. I can then sort those to put them in time order. And then what I can do is now introduce the outlier operator. Because what I'm now doing here is, do I know if 13 or 17 denial of service messages is a lot or a little? Well, I may not. Like I showed with log compare, I need to compare it to something else. So the outlier is going to take those counts of those attempted denial of services and now use a bunch of math against them. When I run the math, the system now starts to develop a lower, a lower and upper range to say, I've looked at previous data points. This is what I think is expected or kind of quote unquote normal. Then it goes to the next time period. Using the math, what is normal changes a bit, but the system says, hey, this value is within this range, it's normal. And that's what it keeps doing. When I switch to the line chart, now what I see is those outliers or those periods of time where there were more or less attempted denial of services than were expected. So if we look at touch before that, here we see the system was expecting, or the threshold was just about 4 to 18. The actual is 14, so that's within that range, and so that's good or acceptable or what have you. Go one step forward, now I see the range has changed. It's now about 6 to 18. The count is 19, which is outside that range. And so the pink triangle is representing that outlier has occurred, something abnormal. Now, once again, I don't necessarily know what's causing that. Well, I do, it's attempted denial of services. But I don't know how to mitigate it or fight it. That I'd have to go to my playbook, but now the system can let me know, hey, this is not normal. You might want to do something about that. The other values up here can be adjusted to adjust the range. And you're really going to need to, I hate to say it, but it's almost a little trial error or really playing with the values to find what's right for you. Because I could set this threshold to a 1. Now my data hasn't changed, but the calculation I use for that threshold has. So now instead of having one time where I have more than attempted denial of services, I have, 6 or 7 more. And I'm even seeing down below, these are times where I had less denial of services than expected. Now, do I want to know that I had less than expected? Well, maybe, but maybe I don't. And that's where with the direction, I can say, don't show me plus or minus, don't show me above or below, just show me above. So now if I get rid of that minus and just keep the plus, now I see over the last 3 hours, there have been, what about 7, 8 bad times where we had more attempted denial of service messages than expected. If I change this threshold to a 3, the threshold grows much more, and now we see we had no times that really exceeded what the system was calculating. So to find out what values to use, you're really going to want to wait for a kind of a normal period of time. I'm using that in quotes because that's easier said than done. But waiting for a normal period of time of traffic, implementing some values, and then deciding, is that okay? Are you getting alerted too frequently or not enough? And then adjusting those values as appropriate. Okay, cool. Lab 7 is a good feature. Actually, Lab 7 was a good feature. That was Outlier. Lab 8 is a good feature, which is time compare. And this is something you may not have seen before. So it's going to be helpful because log compare allows you to use that time shift to say, look at data from here, look at data from there, group it together and compare it. But this allows you to do a similar function, but without the grouping. So let's take a look at this feature, why this is helpful, and the benefit of it. So I'm going to just grab the whole thing again. Okay. So in this case, we're going to look at Palo Alto network data, so firewall traffic data. And what we want to do here is we want to look at the amount of denied traffic for the last 24 hours, and then compare it to the average count of denied traffic for the last 5 days. So that's kind of the goal here. So let's show you how this query is doing it. So the first line, we're saying grab that Palo Alto network data again. Well, actually, we haven't looked at that yet today, really. So grab that data. Now actually, let me even comment off the last portion so to talk through it really specifically. So now we're grabbing Palo Alto network data. Now, the first thing we want to do is we only want to look at traffic data because we only want to see traffic that has been denied or approved or allowed. And so we're saying here, look through the data and look for this string of quote, comma, traffic, comma, to use that to kind of trigger the system to show you just traffic related information. So it's now I see traffic, etc. Now I want to go ahead and say, look at only those denied actions. Now the reason I can do this line is because I have a field extraction rule already in play. So this is letting me know, hey, the system is parsing out action into an allow and deny. And now if I want to say just deny, I can. And that's why I can do this whole line. So now when I run the first line, I'm getting only Palo Alto network traffic data and only those messages that have a deny in there. All right, so now let's go ahead and dig a little bit deeper. Now, even though we just have the raw messages, we want to count them. How many actions did we have? And when we're saying how many actions, we're saying really how many actions that equal deny did we have. So let me do the last hour just because I think it will translate a little bit better. So what we're saying now is over the last hour, we've had 755 denied traffic messages or traffic that has been denied, however you want to kind of think about it. Now, like I asked earlier, is that a lot or a little? I don't know. I need to compare it to something else. And that's what I'm doing in this third line. What I'm doing here is I'm saying compare it with a time shift of 1 day, do it for 5 of those periods, and take the average. So basically what I'm going to do is I'm going to say, look at the last 60 minutes, go to yesterday and look at the last 60 minutes. So from about noon to 1 o'clock, go to the day before from noon to 1 o'clock, the day before that. So take 5 of those days, add them all up, and take the average. Now when I click start, now I see that 5-day average of those 1 hour periods of time. And what I'm seeing is the 5-day average has been 682. Today is 774, meaning we have more denied messages than normal. Is that bad or is that good? I don't really know, but that's where I would then decide. Maybe this is concerning, maybe it's not. What I can also do here through the use of a where statement is I can say, or let's say, I only want to be notified when the count is 2x of that average. So, well, if I'm only, this is 1.2 greater, that's okay. It can be a little higher. But if it's 2x greater, then I really want to know, because that's, more impactful to me in my organization. And that's what this last line is doing. This last line is saying, take the count of the 5-day average, which is 682, at least at this very second, multiply it by 2, and if it is less than, or if it is greater than the count, notify me. So when I click start here, I'm actually going to get no results. And the reason I get no results, and let me confirm I get no results before I get too excited about it, is because the count was not 2x greater. If it was, then we would have seen a result there. And where this can be helpful, as it says with alerting, is that I can now set up an alert. So now the next time I am 2x of the 5-day average, I get notified. And that could happen a month from now. Maybe on a month from now on a Saturday night, it lets me know, hey, compared to the previous 5 days of the week, things were low. Now it's much higher, and then you do whatever you do with that information. So I like showing that because it's a different approach of comparing, and comparing is important because it's really a good way, to let the system decide, here's what was going on, here's another data point, and is it lower, is it higher, and then deciding what to do with based on that. All right, Lab 9. Lab 9 is a great one. Lab 9 is going to introduce us to threat intelligence lookup. So let me grab the query. Let me just talk about all this. All right, so what are we talking about, threat intelligence, and what are we doing right here? Now, in a previous lab, you hopefully saw our geolocation lookup capabilities. The ability for you to take an IP address, turn it into a latitude and longitude, or even a country name, city name, and then start to plot it on a map. And so using a lookup table to take your data, compare it or look it up to some other data and bring that in as well. And so we showed the geolocation, which is quite helpful. But the one we want to show today, specifically because it's around security analytics, is our threat intelligence lookup table. And this lookup table is it is CrowdStrike data. So in the same way that the the mapping geolocation data is not Sumo Logic data, it's a company called Neustar. In this case, for threat intelligence, we use CrowdStrike. And the reason we do is because they're the expert in threat intelligence. So rather than us trying to figure out, are these good or bad IPs and all that, we let them do it. So this is what we're doing here, is utilizing that lookup table. So the first line, or the first 2 lines, you can ignore. I'm really just doing it just more for the demo purposes. But what I want to do here is I want to say, or let's say, I find this IP address in my logs. I see it popping up, and I don't know much about it. And I want to get more information about it. I want to get that threat intelligence about it. This is how I can do so. So in the second line, or the second kind of real line, I'm saying, take this IP address, 84.112, and call it my threat. So essentially equals my threat. And now these 2 lines, it reads easier going from right to left on the bottom. I'm now saying, take my threat, which is 84.112, and compare it to the threat that exists within the CrowdStrike database. And this is the lookup table for that database. From that database, get the type, the actor, the raw, the threat level, which are all just components of threat intelligence and things that might help you analyze the data. And for the threat level, I want to call that field malicious confidence. So right away, I just want to rename it something else. So now I click start. Now what it shows me is this IP address has now been looked up against a CrowdStrike. And what we see is this IP address is known to have a malicious confidence. A high confidence or high malicious confidence would probably be bad, where that's saying it's more than likely to be bad. A low malicious confidence would mean it's not as likely to be bad. Now, to be fair, it doesn't mean that it is a perfectly safe IP address, because I don't know, is there really such a thing? Threats have to start someplace, but what this is telling us is CrowdStrike hasn't been aware of it, it's not known to be bad, and so it's probably safe. Now, if this had said it was high, you once again might go to your playbook and say, if malicious confidence shows up as high, blacklist this IP, or blacklist the user's account, or something like that. If it's low, okay, ignore it. And that's where you would need to decide, how to react to these things, or to react at all. So what we want to show here is that threat intelligence CrowdStrike database that you have access to use. Their data is quite expensive. It costs, I think, 60,000 US or so to access it a year, and we give it to you for free. So, which is, I guess, kind of nice for us to do so. But we will, we want you to take advantage of it. So, look up those IPs, and there's a lot of other things you can look up. So if I go to, I think it's in the FAQ here. While IP address is probably the most common thing you'd want to look up, you can look up domains, URLs, email addresses, Bitcoin addresses, hashes. So you can take all these different, kind of data points in your environment, check them against CrowdStrike. If CrowdStrike thinks they're low or, benign or okay, good. If there's a high malicious confidence, well, maybe you want to do something about it, or maybe you don't. Then that's, once again, for you to decide. So that's a really helpful feature. The next feature I want to show, which is, oh, looks like there's a question. I know Nicholas will get it, but but I'll get it because I actually want to show this. So the question Keith just asked is there any way to do CSV lookups of IOCs on your personal desktop? Let me show you my interpretation of that question, and then if I'm thinking about it differently, Nicholas can go ahead and modify that. Because it depends. You can certainly bring a CSV and import it into the system, and you can also reference it as a lookup table, which I think is what you're asking. So let me show you. I have an example here. Here it is. So what I have here is, let's just go through it line by line. So here I have Apache Access data, which is web server data. And you've probably seen these examples before. We use it quite commonly in Search Mastery and other classes. So in the second line, I'm parsing out that status code. So the status code is going to be a value of 200 or 404, which mean different things. Now, when I run this just as is, I see the status code. Now I see the status code. Now, what is a 503? What is a 200? I may know these or I may not. What I've done here is I've used an outside lookup table. So let me show the lookup table that I'm referencing. So here is the reference table. So this CSV is showing us the status code, the numerical value, and then it's giving us a English, or I guess English, but also more of a simplistic translation of what that is. A 200 is okay or good. A 404 is not found, and so on and so forth. So this is a CSV externally, but I want to use these English or these simple descriptions. So how do I do that? So that's what I'm doing with these lines here. I'm saying take the status code, take the 503, take the 200, whatever it is, and compare it to the value that exists in that CSV. From that CSV, get that description, that kind of simple English description of what it is. When I click Start, now for each status code, I have a simple description. And now I could say count by description. And so now instead of counting by 200 or 404 or 403, now I'm counting by those simple descriptions, which may be easier for me to understand or may not be, but now I can go ahead and do so. So you can reference your external CSV in that way. The CSV can be both password protected or not, up to you. And you can also, just as a reminder, really more than anything, is you can always just ingest a CSV file. So you could always just take a CSV that you have, which you might have been asking about as well, bring it into Sumo Logic, and then compare it against, do the lookup table against CrowdStrike or what have you. So many ways to, I think, answer the question. So let me just make sure I got it. And like I said, Nicholas can go a little deeper. Yeah, so cool. All right, so a little tangent, but a good tangent. Let's do lab 10 next. Lab 11 is actually lookup tables, which I probably should have saved that question for, but it's all good. So lab 10 is query template. So let me show you using the example we started to use already to show you how this can be effective. So right now I have, if we go back to my CrowdStrike little lookup query here, I have this IP address, and when I type an IP address in, I can check to see if it's helpful or not. So if I want to check a different IP address, I change this to a 9.1, run it, and the system will show me if that's good or bad. Now, one thing to point out here, this is just really the CrowdStrike, not really the feature I wanted to show, but if there is no malicious confidence, that means that CrowdStrike is not aware of that IP address. Now, that's where I mentioned earlier. Does that mean it's a good IP address? Well, it's good that CrowdStrike doesn't know it's a bad IP address, but kind of to take it with a grain of salt because things do have to start somewhere. But for the most part, I like to consider it to be a safe IP address, at least for today's discussions. So I can go ahead and put another IP address, and I can do this all day. Now, let's say this query is really helpful for me, but it's also helpful for my manager because he or she has different accounts than me, but they have IP addresses they want to check. So they can go in here and, if I share the query with them, they can do the same thing. But the feature I want to show is what we call a parameterized search, which is something that can make this query have like almost guide rails, if you will. So let me show it. So let's say I give this query to my manager and he or she types their IPs in and, they do an IP. All right, if that's good, they do another IP and, so on and so forth. They keep doing this. But they make a mistake. And for some reason, they just, when they're, typing it in, they accidentally lose that last quotation mark. And now they run the query and they're getting this weird message about control characters, and they might not know what those are. And they might come back to me and say, hey, Josh, I need help with this query. And I might say, hey, I already wrote the query for you. You just type your IP address. And they say it doesn't work. And I want to make this simple for them. What I can do, putting the parenthesis back, is I can highlight the value, including the parenthesis. And when I do, I have this new option that says create a parameter. When I do, click that button, I can name the parameter. So I could call this IP or IP address or something, or I could have just kept the name. I can put a default value. I can start to decide what type of data, as far as when they enter a value, is it going to be a string, a number, those type of things. And then I can even start to set some values for the parameter. So I could create a little lookup table or a bunch of different ways of handling this that allows them to have a pull down of different IP addresses. Now, IP address is probably not the best example because there's, you can't have a pull down of, billions of numbers. Status codes would probably make more sense, but you can go ahead and set up those that in here. But ultimately, what happens when I click save is really the feature I want to show. That field now turns into a parameter, and now the user just needs to enter their IP address in here. They want to check a new IP address, click it in and type it in. They don't have to interact with the query. In fact, I can even hide the query from them, and they know, hey, if I want to check a new IP address, I type it in. It shows me my maliciousness or level. If it's low, maybe I do one thing. If it's high, maybe I do another. And then, maybe I need to check another one an hour later. I don't need to know about the lookup table, about CrowdStrike, about parameters. I just know I type my thing in there, system spits back, good or bad. And so this can be a really helpful feature, certainly for yourself, but also for your peers to kind of interact with them so that you can create something for them, give it to them, and they can benefit from it, but not have to worry about the query language and what's going on, the kind of nuts and bolts. So this is a cool little feature we created. It's been a few months, but it's really pretty helpful. So I wanted to point it out because, yeah, I just like it, especially if you're sharing stuff with other people. It just can lead to less questions, which is usually good. All right, let's look at lab 11, which is lookup tables. So I know there's still a question about them. So let's see if we can help address that through this lab. And this lab is having us, although the lab's a little weird, create our own lookup tables. So previously we looked at lookup tables for geolocation and CrowdStrike. And the question normally you guys ask is, well, what other lookup tables do you have? At this point, we don't have any others, although we're planning to add a few, but I want to show you how you can create your own lookup table. Now in this example, what we're going to do here is we're going to go ahead and look at the snort data. So look at that security event data. Look at the security event data that had a priority 1 alert versus priority 2 or priority 3. And specifically the IP addresses that are associated with those alerts. So that's what we want to look at, and then want to turn that into a table we can reference. So how do we do that? Well, this is how we do it. So I'm just going to paste the whole thing and talk through it again. And just go line by line. So on the first line, I'm using the keywords and the metadata to specify just snort data and just priority 1. If it's a priority 2, a priority 3, I don't care about it. So let me just limit my data set to just those priority 1s. And now I see the keywords highlighted down below. Now I need the IP addresses. So here I'm going to do a parse regex saying look for number. When you find it, parse that out as a source IP. And so now I see a source IP. So this source IP is associated with a priority 1, meaning it's a, let's say it's a sensitive IP or, potentially bad. Now I'm just going to count those source IPs because I want to see how many different source IPs do I have. Well, now I see there's quite a lot of them. What I'm going to do now is create a new field similar to the way I did the row number earlier, but I'm basically going to create a field called blacklisted. And that blacklisted is going to contain the source IP. So now I have the source IP field, the count, and then a field now called blacklisted. Now what I'm going to do, similar to the way I removed that row number earlier, is now I'm going to remove the source IP. And all I'm doing is cleaning this up. These steps are not required, but I just wanted to show them because it does help keep things cleaner. Now what I can do is I can now save this as a lookup table. So what I can do is save and append this to my folder. What do I want to call this thing? I don't know, I'm not feeling very creative with my names today. I'm just going to copy it just so I can reference it later. Now when I click start and run, the system should now spit out a lookup table. Now, did it? I don't know, but let's check. And the way we're going to check is to use the cat command. So what we're going to do is say cat, my folder, look. And now we get those IP addresses, and they still have the count. They probably should have removed the counts as well. Actually, I probably will in the lab. And now we can reference this table. So now we could say, take these IPs and compare them against CrowdStrike or, whatever you want to do. It doesn't have to be CrowdStrike related, of course. So let's see. I'm just going to check on the question. Okay. I think Nicholas is researching something. So, but feel free to have more questions.
I do. Okay.
You want to jump in for a sec, or?
No, I research his question here. So
okay.
Yeah. Okay.
Okay. Cool. Thanks, Nicholas. All right. So, and that's how you could create a lookup table. Now, one question I'm really going to try and get ahead of because somebody's going to ask it is, well, how do I look up my lookup tables? Which is really a pretty innocent question. And to be perfectly frank, right now, there's not a great way of doing it. That's about to change, but let me show you the old way, and then I'll talk about the new way. So the old way, basically, you need to know where you save stuff at. There's not a way to, like I said, cat everything. So you would need to know, hey, I saved my lookup table for IPs here, and the status code's there, and all that. And it's quite cumbersome, and admittedly so. So what we're doing, it should come out really soon, actually, is in the same way that you have a dashboard in your personal folder, you have your queries, you have saved searches, you'll also have a little icon for a lookup table. So you'll have your lookup tables located. Oh, sorry about that. You turn off those hot corners. You'll have them located here. And then you can start to share them using RBAC and with groups and things like that. So that's going to be really helpful. Really looking forward to that feature because it'll make all this a lot easier. So that's really about all for lookup tables. The example here is just having us go through that, which we really just did. The reason why I don't love the last part of this portion here is we create a lookup table, but then we don't reference it anymore, which is kind of weird. But let's show you how to reference it. So in this case, we're going to use the one that already exists, which is called shared /snort alerts. So in step one, let's comment. Oh, I'm sorry, let's forget to. That end pop up. Okay, so what we want to do here is we're going to go ahead and look at that snort data again, those priority ones. We're going to parse out those IP addresses. But this time what we're going to do, and you probably wouldn't do this in the real world because we're really referencing the same thing we just did, but what we're doing now is saying, take the source IPs that are displayed here and compare them to the blacklisted IPs that show up in the snort alerts. And from those, show us where those have been blacklisted. So basically, we want to take the list of IPs we have and see where they compare or where they show up in the blacklist list. Now, what we see here is a lot of empties, meaning they don't show up. Although here's an example. Oh, here's a good one. So this one right here is saying, I found this IP address in the logs, but I don't see the corresponding IP address in the lookup tables. It has not been blacklisted. This one now is saying, this one has been. It shows up in the logs right now. It's already known to be bad or has already been blacklisted, and that's why it's showing up in both columns. And now we could say, show us only where the blacklisted is not empty, because I want to only see those places where IPs in the snort logs match those that have been previously blacklisted. And now I see these 3 IPs have shown up previously in the shared snort alerts. So that's how you can then reference that lookup table that has been imported or well, depends how the lookup table gets there, but that's one way to use that. All right, good. All right, let's see. Lab, let's see, what do we have left? Lab 12. Let's see, I don't like these labs, but they're helpful. All right, let me show this. Actually, these are better than the other ones in Search Mastery. This is the transaction operator. And what this operator does, and like I said, you may have seen it in Search Mastery, but this is a better example, is it allows you to, as it says up here, analyze related sequence of messages based on a unique transaction identifier. So this is where you could take something like an IP address, a session ID, an order number, a phone number, you know, something unique in the system, and start to define various states, and then start to group the messages together when they are in these states, and then start to utilize the state. So let's look at the example, because saying the word states over and over doesn't really help. What we're going to do here is we're going to use the transaction operator to look at source IPs in our web Apache log. So we're going to look at our access logs and look for IPs. And then we also want to see where those IPs are the same or where they correlate to IPs that show up in the snort that have been flagged as a web application attack. So we want to look at the Apache logs and see where we have IPs. And then we want to see where those IPs are the same that show up as a web app attack in the snort data. So that's what we want to do. So how do we do that? Well, this is how. And let's not cut and paste it twice. All right. So in the first line, and let me comment these off, just save them. Okay. So in the first line, we're grabbing the Apache access data, and although we're doing it or, we're also grabbing the snort data, and specifically just snort data that's been marked as a classification web app attack. So we're already starting to limit the snort data that's being returned because we don't need all of it. Now we're going to go ahead and start to parse out IPs. Now, the second line, we could do this with just the third line, but I wanted to show both ways just because. So what we're doing here is we're saying go to the log message, and this is really the reason we're doing this is for the I'm just trying to see if I have any snort messages in here. Let's see, clean this up. I don't want to waste too much time looking. That's not that important. But if you remember when we looked at the snort data earlier, it had the bracket TCP bracket space, and then the first IP address was located right after it. And that's what we're doing with this parse statement, is we're basically saying, go to that TCP, look for that first value, and call that an IP address, or more specifically, a source IP. And I'm going to get rid of the other ones because I don't need those right now. I really just need the source IP. I don't really care about the port. So now I'm going to go ahead and do the same thing, not the same thing, a similar thing to the rest of the messages. Basically, I'm saying for those messages that did not match in snort, which should be Apache messages, look for number, and express that as an IP address. Now, I could have used this on the second line as well, or gotten rid of the second line entirely, but we wanted to just show that kind of versatility with both. So now we have a bunch of IP addresses. And we have a bunch of Apache access messages and a bunch of snort messages, but we need to correlate them, or more specifically, transaction them. So what we're going to do now is transaction. What do we want our transaction? Do we want a transaction on the status code, on the destination port? Well, no, we want to do it on the source IP. And what I'm going to do here is now say, look at the source category and create these different states, Apache Access and Apache Snort. When I do so, the system is now going to basically tick or flag what or where that IP is showing up. So in this first one, it's still loading, but in this first one, this IP address is showing up in the Snort data. It's not showing up in the Apache Access data, and it's also not showing up in any of the other data. This one right here is showing up not at all in the Snort data, but it's showing up a lot in the Apache data. And what we want to find is where it's showing up in the Apache data and in the Snort data at the same time. And that's what this last line is doing. What the last line is saying is look for where lab Snort is greater than 1, and at the same time, lab Apache Access is greater than 1. Now, when I click Start, only those that are greater than 0, or greater than 0, which would be 1, will now be displayed. So now I see of these 4 IPs, and still loading, so it might bring in a little more data. This shows up in the Apache Access messages, certainly a ton, but it does show up in the Snorts as associated with the web application attack. Now, once again, what do I do with that? It's up to you to decide. Do I immediately blacklist it? Maybe. Do I monitor it and see what people or users associated with that account are doing? Maybe, and I need to decide that. Now, what we had even in here, this is a good example. I forgot about this. In step 2 is what we can do is now that we've identified the IPs, we can use the threat intelligence lookup to see are these IOCs or potentially bad IPs. So what I'm doing now at the very bottom of the line is I'm now saying, take that source IP, and now that we know it shows up in Apache and Access, compare it to the CrowdStrike database, and from that grab the malicious confidence and all that other stuff. And so now when I run this, now I see of those, what was it, 4, I think it was 4 IPs. Now for each one of them, I should see, because of that line, sorry. Now I see the malicious confidence. And once again, in this case, these are showing up as blank, which is probably okay. But if it showed up as low, I might do one action. If it showed up as high, I'd probably do a very different action. And so that's where the transaction can really help you with that, is start to define these different states or groupings and see where it's coming into this group, and then do something with that or not. All right. Let's see these next ones. I'm gonna skip over these 2. Actually, so the one I'm skipping over, I'm sorry, I should have vocalized why we're doing that. Lab 13 is transaction eyes, which is pretty similar. As it says here, the difference from the transaction operator is it aggregates the search results. Let me see. Yeah, I was having issues with this lab earlier, so I'm gonna skip it just for that reason. And lab 14 is subqueries. Let's see, just checking in on question. And subqueries you probably saw earlier, but let's go through again. Yeah, let's go through pretty quickly. What I want to really have you understand about the subquery, and subqueries themselves are not unique to Sumo Logic, so if you've used them in other worlds or other languages, you get the gist of it already. But where these come in helpful is the fact that you can take a set of data, extrapolate out a value, and then pass that value to another query, and then have that query continue to run. So let's look at this one. This is it's an okay example. So what I'm doing here is, and let's see how should I do this. Let me break this up into 2 queries. So let me have, here I have a child query, and here I have a parent query. And basically what I want to do is I want to run the child query to produce a result as a keyword, which I'll show this query in a second. And then I want to pass that keyword to this query to look at that IP address through the Apache Access data. So first I'm saying, look at the Snort data and the web application attack data like we just did, and parse out those IP addresses. So basically, I'm now getting IP addresses associated with web application attacks. What I'm doing here is I'm basically running this and producing a single IP. And I'm sorry, I should have showed the IPs. So here are all those IPs. What I'm doing now is I'm basically saying, take those values of source IP and look for them as a keyword. So it's almost like I'm doing, and then I'm going to run this, and then run that, and then run that. So what we're trying to show here is the example's okay, but what I really want to show is the fact that you can take, as it says here, a query, pass results back to another query to help narrow down the sets of the messages that are being searched in those queries. So as a keyword, basically you can bring that keyword as a value in and help it reduce what you're looking at. So for that one and many of the things that we're going over today, like you probably experienced before with these trainings, I'm not concerned with you knowing, this, although I'd like you to know the specifics on the subquery, but really, if down the road you think, oh, I wish I could transfer, one value from one query to another, subquery might be the way to go. Now, certainly CSV and lookup tables might be the way to go as well. It depends, where the data comes from, and just really personal preference almost to some degree. All right, looks like Nicholas and Keith are still talking about CSVs, but that's cool. Keep going on with that. Lab 15 and 16, I'm going to skip over only because at this point you should have done these. And if you haven't, I'd encourage you to go over them on your own time. But what they are is creating and publishing a dashboard. So I feel like at this point you probably have done a dashboard at one point. And like I said, if you haven't, I do go through it, but it just that feels a touch repetitive. Same with Lab 16, because Lab 16 is then taking a dashboard and adding panels, which you probably have done already. So yeah, I'll skip over those. I don't think we need to do them. Lab 17 is, I'll show it because you may have seen it elsewhere, but it's worth showing. Yeah, it's worth showing because what we can do is alert on new security attacks. Now, we kind of looked at this a little bit earlier with the log compare, but what I didn't show earlier is that is new. So let me show it now. Probably should have just showed it earlier, but let me show you now, and more importantly, why you'd want to use it. So what I'm doing now is I'm really getting back to kind of where I was a while ago. So what I'm doing is I'm looking at the snort data for the past 60 minutes, so about call it 12:30, 1:30 local time. I'm doing a time shift from 12:30 to 1:30 yesterday, looking at those snort messages and then grouping them together based on just different, AI and secret sauce and fancy words. Now, this is good. This shows me, oh, we even have an example here, even better. This shows me, have I seen an increase or a decrease, it actually should be vice versa, of these things compared to yesterday. But what it also shows me are those things that are new, meaning yesterday from 11:30 to 12:30 or whatever time range we were doing, there was not this thing, and today there is, which this is quite important to know that today there's been a Trojan detected, yesterday there was not. But it also shows us those things that are gone, meaning yesterday at this time, there was an attempted denial of service, and today there's not. Now, the is new is something that you guys are usually interested in finding out, because when something new happens in your environments, it's not always good. It's not necessarily bad, but it's usually something you want to know about. And so you can go ahead and create this query of simply where is new. Now what this is going to show me is when I have something in my 60-minute window, what occurred in the 60-minute window 24 hours ago, and then only those things that are or is new. And now it should produce that one new thing. Now that's good, very helpful to come in here, do a search and see what's new, but we want to automate this. Let's turn this into an alert so that the next time something new happens, you get notified or your team gets notified, and then you can go ahead and go to your playbook or do whatever you do. To set it up is pretty easy. Click on Save As, and rather than saving it, although saving things are always a good idea, just scroll all the way down and go to Schedule this search. Click on it, and then you're going to decide how frequently do you want this thing to run. Real time, every 15 minutes, every 2 hours, custom cron, up to you. I just encourage real time because I want to know in real time the next time something new happens. I don't want to wait for an hour, but I could. So it's just up to me to decide, kind of what granularity do I want to get those alerts with. But real time is, I think probably the way to go. And then you would just really leave this portion. If the condition is met greater than 0, meaning there is something that is new, so the is new is 1 versus 0, then you could go ahead and get an email or send an email out to people or send a Slack message via a webhook. And so you have all those options. And then you would just decide to click save. And so the benefit of this is now the next time something new happens, it's going to notify you. So maybe like I gave earlier, next Saturday, it lets you know, hey, from 11 to 12 tonight compared to 11 to 12 Friday night, something new happened. You get notified of that via email or via Slack, depending on your preference. And then you go ahead and go to the playbook or resolve it or contact somebody else. Do whatever you do with that. So those alerts are going to be really helpful. I mean, I feel like you probably know the benefits of alerts already. I hope I don't have to sell you on them. But really, to almost a touch, ironically, keep you out of Sumo logic and still benefit from what's going on in it. So alerts are good. Lab 18, I'm going to skip over only because it's the same. It's pretty much the same, close enough at least, to the example we look at in Search Mastery. And what it's doing is pretty similar to what I just showed you. So what we're doing is we're creating an alert, but in this case, we're creating an alert using Outlier and other things. So in this case, rather than saying just show us where things are new, we want to say show us where good and bad things are happening, and then start to count the goods, count the bads, turn it into a ratio, and then let me or let somebody in my organization know that we are outside that outlier range, that threshold range. So I'm going to skip over it, but if you haven't gone through this before, I'd encourage you as well, but I just kind of feel like you have. And then I'm going to go to Lab 20. Let's finish it off with Lab 20, and certainly we'll leave time for questions. But Lab 20 is a good one because it introduces the Threat Intelligence app. So apps you've probably seen before, but let's go through them because for this use case, they're even more helpful. I'm just going to grab this just so I remember, but let's go into the system and look at this. So I'm going to go to the app catalog. And what the app catalog is, as a reminder, if you haven't seen it, is it's a bunch of queries and dashboards that we at Sumo Logic have created for a bunch of different sets of data. So we know what Apache data looks like. We know what CloudTrail data looks like, and other people do. We're not super unique in that. And so what we've done is we know that for Apache data, the IP address is going to be first, and then there's going to be the time, and then later the status code. And we know the format of that. And so with the app, we can provide you queries that we think will be helpful for those use cases to help you look or investigate your data with queries that we're giving you to help ideally save you time. So let's look at one that actually uses the Threat Intelligence app or data. So I'm going to go ahead and look for Threat Intel Quick Analysis. There's one for AWS. I'm just going to use this one, even though I'm going to look at AWS data. And what I'm going to do is click Add to Library. So first, I'm going to give it a name. Technically, I really could just keep the same name, but just if you're in the training environment, you might have to modify the name. And then I'm going to tell the system what set of data I want it to look at, or what set of data I want it to reference. And the set of data we're going to use is ELB data, which is AWS load balancing data. So I'm just going to copy or type in that source category. And then I'm going to click Add to Library. And so what's happening now is similar to a regular app. We're taking a query, we're taking a dashboard and applying it to the set of data. At this point, we're also bringing CrowdStrike. So we're taking our queries and dashboards, your data, and CrowdStrike's data or intelligence, and grouping it all together. So now, for example, I have a Threat Intel Quick Analysis. Let me just expand this out a little bit. Overview. Overview is always a good place to start. And now I see here are the number of log lines that have been scanned over the last 15 minutes. Here's been the number of threats that have been counted. And keep in mind, this is demo data, so it's a little, we've kind of played with it. Here's the URL threats, so on and so forth. All this stuff that might help you. We can even go a step deeper into domain. I think it's domain that shows it. Yeah. So what we see here is similar to what I was showing you, the threat count, threats over time, so on and so forth. But what we even see here is the system has found these different domains within our ELB data, and it's letting us know, hey, these are known to be a high malicious confidence. There's 4 of them. Now, once again, what do I do with that? Well, that's where I need to decide, but I don't know, I probably want to monitor these or, look after them or something with them. So, and that's where you could then decide. And of course, you could have an alert that says, the next time you have something of a malicious confidence high, a domain, alert me or alert my security team or, whoever needs to get involved. And so those are really the things we wanted to cover today. Like I said, earlier, it's really, it's the same query language, that hasn't changed, but it's with that security hat on mind. So using the CrowdStrike data for the threat intelligence, using the lookup tables for both maybe your data or, data you want to reference, those query templates that parameterize search to make the queries just easier to interact with. Certainly doesn't advance the functionality, but it does make it easier for people that might not understand Sumo. And then transactions, some of those other things. So I'm going to go ahead and check on questions. I know you guys have been chatting away, which is great. So, please keep that up. All right, looks like you guys are in good spots.
Yeah,
So,
I don't think there are any questions.
Okay.
Okay.
Cool. Thanks, Nicholas. And certainly, if any do ever pop up, we want you to let us know. So questions are always good. So what we're going to do now, unless there's any other questions or any tangents even you guys want to go on, is probably just take the exam, get that kind of rolling. So to do so, I'm going to assume you guys have kind of gone through this before, but still remind you just the same. The first thing you'll want to do is make sure that you either log out of the training account or you use a separate tab or even a separate browser for your kind of your corporate or your professional account to take the exam. We just don't want you to take the exam as the training user. If you do, and it happens a lot, just let us know. We can modify it for you, but ideally you'll log in as yourself. If you don't have a login, if you want to just go ahead and put it in the Slack or in the chat rather, we can help you with that. But it's only a couple of you. I think you guys have logins already. And so we'll go to home, or we'll be brought to home when we first log in. And then we'll go to certification and security analytics. The prep, which is what we just did, the webinar is me doing the labs like I did and just talking through them. And the hands-on labs are the labs that you had access to. I hope I gave you enough time. I'd realize in hindsight I did kind of talk through them. So I do apologize if you were hoping to have a little more time with the labs. And if you need more time with them, certainly feel free to go through them. But what we'll do now is, or if you want to wait a little bit, that's really up to you. Now we would just take the exam. So you'll take the exam. As a reminder, it's an open book exam, open resource exam. We'll be on the phone for most of the time with you guys. Yeah, 30 questions, multiple choice, 75 to pass. All those kind of rules are the same. So you've probably done that already. So let's go ahead and start it. Like I said, I'll be on mute. Nicholas will be as well. So if any questions come up, feel free to chat them in and we can either address them specifically, or if it's a more general question, I might just jump in. But yeah, let's start to take the exam. And certainly, we'd encourage your peers to join in on these as well. So if they weren't able to attend, they could still go through the webinar and the labs on their own time, or you can as well. And, just do more of a, not self-paced, but, at your own rate. So thank you everybody for attending. Hope you found this helpful. We will also be sending out, I forgot to mention, a link with a link to slides, although I didn't really use them. We do have slides that go along with this, as well as recording. The recording probably won't be of this specific session, but it will be the same thing that we cover all the time. So I'll send those out later today or tomorrow, just depending on when I get to it. So, all right, cool, everybody. So good luck on the exam. I'll go ahead and put myself on mute. Nicholas will be here as well. And yeah, just good luck, everybody. So thank you again.